In this video, I want to talk about Lagrange's theorem. Let's let G be a finite group and H be any subgroup of G. Since we have a subgroup, we have partitioned G into cosets. I proved in the last video that this did actually form a partition. We also proved that all the cosets have the same number of elements, which is also the same as the number of elements in H. Then we can say that the number of elements in my group G is equal to the number of elements in H multiplied by the number of distinct cosets in H. What Lagrange's theorem says is if G is a finite group and H is any subgroup, the order of G is a multiple of the order of H. And this is exactly what we just showed. Not only did we show that it was a multiple of the order of H, but we explained exactly what multiple that was, the number of cosets. But this also tells us something else. It tells us that the order of any subgroup of G is a divisor of the order of G. So I can actually talk about what different sizes of subgroups are even possible. As an example, if we have a group G that has 15 elements, its proper subgroups may either have 3 or 5 elements, and those are the only possible options. If my group has 7 elements, then there are no possible subgroups. The only numbers that divide 7 are 1 and 7, and those would not be proper subgroups. One big result of Lagrange's theorem is that the order of any element of a finite group divides the order of the group. And this results from the fact that I can just look at the order of the cyclic group generated by A. We know that the order of the element is the same as the order of the cyclic group, and we know that the cyclic group would be a subgroup, and its order has to divide the order of the group. Let's let G be a group with a subgroup H. The index of my subgroup H and G is the number of cosets of H and G, so the index is the number of cosets. And we denote this with parentheses, G:H. So what Lagrange's theorem actually says is the number of elements in G is equal to the number of elements in H multiplied by the number of cosets. And another way we often see this is the number of cosets is the order of G divided by the order of the subgroup.